Welcome back everyone to another video in our structural engineering course. In this video, we are going to learn about stability and determinacy of trusses. Stability and determinacy of trusses is very similar to what we have learned in beams and frames. Trusses also stability are divided into two main types, external stability and internal stability. For external stability, the same rules that we have discussed earlier in case of beams and frames is also applicable here, which in case of all reactions were found to be parallel, this means that this truss is externally unstable, and also if all reactions were found to be concurrent at only one point, as you can see here, all reactions are connected to this point. This also means that this truss is externally unstable. So what about the internal stability of trusses? Internal stability of trusses could be checked using this formula, which is M plus R equals 2J. This means that the truss is stable and determinate. M plus R is more than 2J means that the truss is stable and indeterminate. And M plus R is smaller than 2J, which means that the truss is unstable. This is where M is the number of members, R is the number of reactions, and J is the number of joints. So now the stability and determinacy of beams go through the following flowchart. First, you check the external stability of the truss, and this is also applicable for the beams. If it is found not okay, this means it is unstable. If it is found to be okay, we need to check the internal stability. We go to these three equations or these three cases of the equations, which is either M plus R is more than 2J or equals 2J or less than 2J. Of course, this equation is in case of trusses, but we have different equations for frames and for beams. And for each case, we found if it is stable and determinate or indeterminate or unstable. So now, let's have an example on this. We have here this truss, and we want to determine the stability and determinacy of it. In order to do that, we will start first by counting the number of members that we have here. We have 1, 2, 3, 4, 5, 6. You need to take care that this is counted as only one member, and this is only one member, not two, because we don't have a joint here. As you can see, there is no joint here, which means that these two elements are actually not connected to each other. So we have 6 members. Now we need to calculate the number of reactions. We have here 2 reactions because this is a hinged support. Here we have only 1 reaction because this is a roller. This means that R equals 3. After that, we calculate the number of the joints. We have 1, 2, 3, 4, 5. And we said that this is not considered as joint because we can't see this dot here. So this means that they are not connected. So we have only 5 joints. So now we can calculate M plus R, which is 6 plus 3 equals 9, and 2J, which is equal 10. So this means that M plus R is less than 2J, which means that this truss is unstable. So the answer is the first option, which is unstable. So let's have another example also on truss stability and determinacy. We have this truss, and we want also to check the stability and determinacy of this truss. We will start first by counting the number of the members that we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we have 19 members. And for the reactions, we have 2 reactions here, vertical and horizontal. Here we have only 1 vertical, so we have 3. And for the joints, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 reactions. This means that M plus R equals 22, and 2J also equals 22. So this means that M plus R equals 2J, which means that this truss is stable and determinate. So this is the answer, which is the second option here, stable and determinate. So this is it for our video today. See you in our next video. Thank you.